Okay, just wanted to cover a very interesting and neat project that I've been privileged to work with out in California, Southern California. I had the opportunity to work with two educational institutions out there, one at the K-12 level, which is the Lewis Center for Educational Research. Also, okay, I'll hold it up. There are drawbacks for being tall. Okay, we also, in this project, in developing a desert panicgrass, we worked with Victor Valley Community College there in Victorville, also with the local Mojave Desert Resource Conservation District out of Victorville. So it's a very local but very collaborative project between several entities there. Got the opportunity to work with two different groups of kids, one at the high school level, one at the college level, with their mentors and their instructors. And so it was very rewarding from that standpoint. I think we accomplished a lot of good, accumulated a lot of information on the potential for this grass in some southwestern desert river systems and riparian systems. Oh, how did that get in there? How'd that get in there, Sparty? All right. You know, as a long-time former resident of Colorado for about 30-some years, and now in California, I'm still a Broncos fan. And I was driving here over the weekend, Sunday and into Monday, and listening to that all the way, and good for the Broncos. Glad to see it. All right, let's discuss a little bit about what panicgrass is. Desert panicgrass, also known in other parts of the Southwest as silky panicgrass, Panicum urvilleanum. It's pretty unique. I'll show a map here in a second. Very commonly found in the lower Colorado river system, also the lower Mojave River system. It's a grass that provides a very important ecological niche in the sandy soils, sandy portions of those two river systems. And that's pretty well where you find it, only where you'll find it is in those. But it plays an important role because in the southwestern desert, any of you that have worked in the southwestern desert in that particular vicinity of southeastern California, the Mojave Desert, in other words, both the low desert and the high desert, as they call it out there, you know that perennial native grasses out there are kind of few and far between. And this is one that's out there in these river systems, and we wanted to take advantage of it to see if we could use it for some revegetation purposes, not only on the river and riparian systems, but on some adjacent upland systems to see if we could address some erosion control problems. You also find it on some of the creosote bush scrubland that's adjacent to the river systems down there, particularly on the Mojave River system. Generally less than 1,000 meters in elevation is the range where you'll find this. One of the interesting things that you'll see, one of the key identification characteristics of this, you know, it's a typical panicum in many ways. It's got the height of a panicum, it's got the branched panicle inflorescence of a lot of the panicums that you see across the west. But one of the ways that you can really identify this is the real silky hairiness of the florets. You look at that, and it's pretty well unmistakable when you see that you're dealing with the desert panicgrass when you see it in these locales. Here's a general description of where you'll find this. Primarily southeastern California, southern Nevada, western Arizona. They do have one identification of it down in southern Texas, but primarily it's right here on the lower Colorado main stem and the tributaries and on the lower Mojave River system. The Mojave River, that will be, I'll point out here in just a minute, is probably one of the very, very rare rivers in California that flows to the north, as opposed to nearly everything else that flows the other way. This is a typical setting scenario for where you find desert panicgrass. This is the Mojave River floodplain. The Mojave River is an ephemeral river. As of probably the mid-1980s, we've heard a lot about changes in dams and their effects on streams, and This is a dammed river as of the 70s, and it was a perennial stream nearly all the way down almost to Soda Lake near Baker, California, until about the early to mid 80s. And then pretty much it went underground at that point, became an ephemeral stream on going as far as surface flows. But this is characteristic of where you see the desert panicgrass. That's what this is in the foreground through here. You find it typically also in association with shrubs that are in the riverbed and in the riparian system, namely tamarisk. We've got 2 or 3 species of tamarisk there along the Mojave system. We also have further down, lower down as you get toward Afton Canyon and Soda Lake, you find a lot of mesquite. But wherever it builds up on the leeward side of these shrubs, this is an old tamarisk, a young one, stand of tamarisk back in here. This is where on these leeward dunes that build up behind these shrubs, this is where you see a lot of this panicgrass existing. It can exist out in the open and do well out here, but it also tolerates complete cover. It reminds me very much of Indian rice grass in the great sand dunes here in Colorado. It can be covered, come right through it. It can be covered and come right through it. One of the interesting things is you dig down in these little dunes behind the shrubs, you'll find out that, as I mentioned in the early description, most of the descriptions of this plant, they refer to it as a stoloniferous plant. It probably is truly stoloniferous, but they look an awful lot like rhizomes when you really get down to it. And you dig down through these dunes, and you'll see that the stems go down through all that fine sand and keep going down, almost like a modified stem, but it is actually stem material that keeps emerging and coming through the sand. And the stolons will be down here at this bottom level, at the bottom of the dune, where it encounters typically a cobbly or a gravelly sandy loam or gravelly loamy sand underneath as a base material for the river flows. And that's where those stolons spread out and go laterally for several feet. It's a very drought-hardy plant as a result. We collected seed on this. The seed collection period is typically toward the end of May, early June. Again, if you were up in this country for a panicum, that'd be a little bit early. Out there in the Mojave Desert, this is about the right time of the year to do this. One of the primary reasons, as I mentioned, that we really wanted to see what the potential was for this grass is to deal with erosion, particularly wind erosion on river channels, the adjacent riparian areas, and adjacent uplands or what we would call secondary or tertiary river terraces, floodplain terraces, and on up into the adjacent uplands where they have cropland that's going to be retired very soon. And I'll get into more detail on that in just a minute. It holds great potential. As you can see, here's more of the panicgrass right in here doing well in attempting to hold down some of this sand movement. Mojave River channel is right here at the bottom right of the slide. The sand is moving out of the channel, moving up on the uplands, which are creosote uplands, up through here, pretty much in a strong wave of desertification ever since the 1980s when it stopped being a perennial stream. Here's one of the reasons why we want to have this as a tool in our chest for erosion control. This is a common scene along this portion of the Mojave River. This is a garage that has been covered up with the sand. You can see the house back in the background. This is the garage that is now really well insulated on that one side. They don't have to worry about heat getting to that side of the garage. You can see as this moving through, this is actually one of the paved roads that crosses north and south through the river channel itself on the Mojave River. And it's not unusual in this part of the country on the Mojave, and perhaps in some places on the lower Colorado system as well, where you can get sustained winds of 40 to 60, 70 miles an hour that will stay that way for days at a time. And so this is a very critical area to try to control the sand movement out of the channel and up onto the riparian areas and the uplands. This is the agriculture that I mentioned. There's a lot of agriculture in a valley that I'll point out in just a second called the Newberry Springs Valley. A lot of center pivot agriculture where they have irrigated alfalfa. A lot of that agriculture is going to be going out here in the next 10 years in that basin simply because they're losing their water. They project the Mojave Water Agency, which manages the water for the whole high desert area, probably projects that much of that valley, where a lot of this center pivot irrigation is going to lose their ability to irrigate completely in about 10 years. We've got a lot of land such as this that's going to come out and be retired, come out of production, and we're looking for a mix of species to help revegetate a lot of this former cropland so that it doesn't start to blow, because these soils are much the same. Whoops, sorry. The soils here, even though they look productive, they're still much like you see in the background on the Creosote and then the river just on the other side. They're mostly loamy sands to sandy loams that they've converted over the years, ever since the 30s and 40s. Grown alfalfa on it, now they're going to go out, and we need to be revegetating these to keep them tied down. All right, we collected seed in May and June of 2014. We had volunteer groups from these two schools come out, along with some assistance from NRCS people, and they spent 2 or 3 days collecting seed of Panicgrass in about 5 different locations. One of the reasons we collected in this year is because of the precipitation that was received 2013 and 2014. If you look in this particular area from July of 13 to April of 14, we had 119% of what they normally get in the whole year. And what was even more important than that is at the timing. We had pulses of that rainfall that came in August and November that were very critical on popping the desert Panicgrass up along the desert in those river channels and the riparian zones. Probably spring of 2014 revealed 10 times the amount of desert Panicgrass that we've seen there in that river system before. The amount of rains, and particularly the timing of it, really popped it out, and so we took advantage of that timing to go out and collect seed. We didn't want to let that opportunity bypass us. Give you a little better idea of where we're at in Southern California. We're down here in the southern part in San Bernardino County, just east of Barstow. This is on what they call the high desert. This is a little better shot of the valley that we're talking about that I mentioned a minute ago, Newberry Springs Valley. We have Barstow on the far west edge. It extends between Interstate 15 heading to Vegas and Interstate 40 heading to Needles. There's a little triangular shaped valley right in here where a lot of this grass grows. This is where we did a lot of our seed collection. We collected in 5 areas within this valley. We collected just east of Barstow. We collected on Mineola Road, Harvard Road, at Camp Katy, and this is a progression, as you go from west to east. This is a portion where the river does go a little bit to the east, but then it'll curve to the north again shortly after this. And then we had a 5th collection site much further on down, getting much closer toward Baker, California, called Soda Lake. We sent the seed to the Tucson Plant Materials Center with NRCS in Tucson. They're one of our partners that we have with this particular project. They cleaned and conditioned the seed for us. As you can see, much like many panicums that we have out there, it cleans up really well. This is the collected florets, clean seed. Of the 5 collection sites, we had enough seed really to move forward with some greenhouse research and some field plantings later on, with just 2 of the accessions, the ones that we collected from Mineola Road and from Harvard Road, and so those are the 2 accessions out of the 5 collection sites that we moved forward with. We collected about cleaned weight. We had about a pound of seed for the Harvard Road, about a pound and a half of seed for Mineola. As you can see, in terms of tested germination, we're running about on total germination 70-75% for the Mineola, about 50% for the Harvard. We wanted to do some testing on this grass to really see, does it have that ecological amplitude, flexibility to be useful to us as a revegetation species? In other words, does it have the ability to adapt to soil textures other than some of the loamy sands and the fine sands that we find in the river channel and the riparian sites? Will it move up to some of these little more upland sites that are more characteristic, more dominant loamy sand moving into sandy loam? We want to evaluate that to see if you're able to tolerate that. We also wanted to look at seeding depth tolerance. As you saw in a previous slide, the best we can tell, germination of this seed does not occur right on the surface when the seed is shed. It burrows down into the sand, and it's covered by the dune sands and the blowing sands at the time. Germination occurs at a lower level, not right on the surface. And so we wanted to test and see in terms of revegetation approach, seed depth placement, or did it work? Did it work on the surface, or did it work deeper? Stratification. We wanted to see about stratification needs. A lot of panicums, particularly in areas that undergo cool winters, and on the high desert, we do have cool winters that will get down into the teens at times. A lot of panicums have dormancy mechanisms, physiological dormancy mechanisms that need to be broken. Stratification is one way to do this. So we wanted to see if this species had a need for stratification to break some of that dormancy. We did native soil collection from the sites that they were collected from for the greenhouse experiments. We did the deep 40 deep pods. This is the experimental design that we did, looking at adaptation to 3 different textures of soil, seed depth placement, and stratification, number of cells and so forth that we went through, number of seed. We did irrigate in the greenhouse application. We started with surface irrigation. Then after germination was started, we went to sub-irrigation in the bottom of these trays that you see. Here's at 14 days post-seeding. The little seedlings coming up. Here's some of the results that we had in the testing that was done by the high school group and the college group that we were working with. What I want to point out mainly is this is in regard to soil texture adaptation, fine sand, coarse sand, sandy loam, or loamy sand. Each institution had a little different twist on it. The main story to get out of this, even though we saw Mineola accession being a little more tolerant of some of the fine sands, generally we found that it is adapted to even going all the way up to loamy sand or sandy loam. It has a pretty equal adaptation to this when you take it out of that environment and seed it in something that's a little finer texture. We looked at seeding depth. Here's where the real difference showed up. They do prefer the deeper seeding depth. Each institution looked at a different depth from 1 inch to 2 inch, very consistent, very significant. That definitely likes the deeper seeding depth, going all the way down to 2 inches. In terms of stratification, we found out that basically it didn't need stratification. In fact, even though there's no significant difference, they probably preferred not to be stratified, have a full treatment. So those are the things that we were wanting to know to help us with some of our revegetation approaches. At 90 days post-seeding, they looked like this, and they were ready to be taken out of the greenhouse. We took them into a shade house outdoors from the greenhouses where they were grown at the 3 institutions. Here's what they looked like in October 2015, just this last fall. We went back out with those transplants to several different locations. We went to 4 different locations with the transplants for some trial plantings. Basically, we have 2, one over here that stayed at the Lewis Center site, and also at a farm here on the east end of the valley that were what you consider common garden plantings. We had 2 others that were reciprocal plantings right here. We also did 2 field trial seeding sites, one at Camp Katy, one at Hilarities. This is kind of a wind scour type site with kind of an erosion pavement that was worked up through some seedbed preparation. This is a site that's more of a sand deposition site next to the river channel. Here's what the field plantings look like. We protected them with some of the mesh rabbit guards to keep the rabbit herbivory down on them. These are just a selection of a few that we put out in those 4 locations. And then we also sent a lot of the seed that we collected to the Tucson Plant Materials Center. They're now doing seed increased fields on that. We hope that's going to lead here in a matter of 2 to 3 to 4 years to at least what we call a pre-cultivar source identified release of this material that can be used in the lower Colorado, Mojave River systems for revegetation on some of these highly erosive sandy sites. So that's what we tried to do with the project. Thank you.
For Ken. Oh, there we go.
For the grow out that you're doing, did you pick one collection, or did you pull the two and just have them grow a pool collection?
We're doing 2 accessions, the Mineola and the Harvard Road accessions. Those are the ones that are going to the field trial plantings. They were also the ones done in the field seedings that we did out there in the Newberry Springs Valley. And then at the Teton Plant Material Center, they have the same two accessions, plus they have the seed from the Soda Lake, or excuse me, not Soda Lake, but East Barstow. We didn't feel we had enough to spread among the institutions for the greenhouse testing, but we did have enough to send to Tucson. So Tucson's got the 3 accessions that they're developing in the seed increase field.
As a follow-up, are you going to put that seed back in specific places, or are you going to try it, say, both varieties in the same field, or are you going to try to experiment more with that, I guess?
Yeah, we're going further with those field trials. We've got them, both accessions in some common garden in 2 locations there within that Newberry Springs Valley. We've also got them reciprocal to see how well they tolerate where each one came from. Where the Mineola is getting seeded as well as planted in where the Harvard Road came from, and vice versa. We've also got additional field plantings that we've done that I haven't gotten any results back from, but it goes further east toward the country. If any of you are familiar with that country, near Joshua Tree National Park. It's not on the park or near the park, but it's in that vicinity, approaching that area where it's still the same type of sandy soils, but it's more creosote bush, arroyo type of country, and we're trying it there too. It's got a limited jurisdiction, so to speak, of where it's going to be available to use, but in those southwestern desert river systems, I think it's going to do really well. It was very encouraging to us that it had the adaptation to different soil textures. That enables us to put it in with some seed mixtures and use it on some of those fields that are going out of agricultural production, which most of them are within 2 miles of the river system. But it's going to equate to about 6,000 to 7,000 acres are going to come out of production here in about 10 years.
Any other questions?
Thank you.